So you've talked a little bit about or looked at the video about unit rates. So we're going to take unit rates and push it a little bit further here. So here's EE5, graph proportional relationships, interpreting the unit rate as the slope of the graph. We're going to compare two different proportional relationships represented in different ways, okay? So if you are unclear about proportional relationships, then I will link in a different video for you to watch. I don't expect you to say, well, I'm not going to ask you questions or anything. It's something you can do on the side if you need to do it, okay? And you might be able to skip through it a little bit, but it's more of if you have a little bit of a trouble with this idea of what proportions are, okay? So let's just go ahead and start moving through here. Okay, so here's what we got. We got unit rates, right? You watched that already, where we compared two different quantities of different units, where the denominator is 1. One example there would be miles per hour, okay? Speed of something. So now we're also going to talk about this idea of slope, okay? So slope is sort of like the steepness of a line. Like if you're going to go, typically people talk about it when they're thinking about like a hill or something, right? If it's real steep, it goes up a lot, right? It doesn't travel left and right very much. It's very steep as when it goes up very much, okay? Or if you're at the top of something and looking down, it's very steep if it drops very quickly, okay? And then something is almost flat if it doesn't really drop at all, okay? And so then we're going to describe sort of how the line moves. And don't worry about this idea of slope, okay? For right now, as far as like really fully understanding it, we're going to really dive into that a little bit more after break here, okay? So I just want you to have a sort of a general idea of what this is, and hopefully you can identify it on a graph. Okay, so here's what we got, okay? And this is essentially what we need to do with this standard, is we're basically looking at two different things, explore two different ideas here, okay? Where there's the same units for rate, but we're talking about two different things that are happening. So like for instance, I've got car 1 here. It's traveling at d equals 40t. That's how we're representing how it's moving. And I've got car 2 over on the right side here, and this is how I'm representing the move, okay? So this is describing the miles and the number of hours, okay? So you can look at this one and you can sort of look at this as a series of points, right? So I can look at it, this is 1, 30, right? So after 1 hour, I've gone 30 miles. 2 hours, I've traveled 60 miles. 3 hours, we've traveled 90 miles. And from there, I'd hope that you could find the speed at which it's traveling, right? So that would be the unit rate. Is what I want to do is I want to talk about the number of miles, right? Well, there it is. Okay, the number of miles in 1 hour, okay? So that would be 30. Well, now this one, let's talk about the same thing. Okay, so this is a over here what I've got is an equation that talks about d equals 40t. Okay, so d equals 40t. This is distance is equal to rate times time. Okay, so distance, whatever unit we're going to use, and then time. We're going to assume that since this is a car and we're comparing another car, we're going to assume that the rate is using the same units, okay? And so since this one is miles per hour, right? Since it's miles per hour, we're going to talk about this one as in miles per hour. All right, so if distance, right, if this is the number of miles that I travel and t is the number of time, then this in here must be the rate, okay? All right, this is 1 unit, okay? This is the total, right? Total distance I've traveled. This is the amount of time that I've traveled. So this must be the amount of distance I travel for each one of the hours, right? So if I travel for 1 hour, I've gone 40 miles. If I go travel 2 hours, I will have gone 80 miles. If I travel for 3 hours, I'd be 120 miles, okay? And so here what I'm looking at is the, where is it? Okay, I'm traveling at this one at 40 miles an hour, okay? And if I wanted to look at this on the graph, what I could do is I could look at this on the graph, and I could see that the pink line here is the car 1, right? Pink is car 1. And then the green one is car 2. So you can see from here that the green one, car 2, is traveling at a slower pace, right? Or car 1 is traveling at a quicker pace because they can travel this in the same amount of time. The car 1 travels a further amount, right? This one in 1 hour only goes 30 miles. This one goes 40, okay? And so this line is a proportional relationship, right? It starts at 0 and it follows a consistent pattern, a consistent multiplier, and it moves on and on and on, okay? Now, what we'd look at here is we'd look at this idea, this rate, okay, the way that this line is moving, okay, the speed at which it's traveling here, right, the miles, per hour, the unit rate is the same thing as what we'll call the slope, okay? So the slope, the idea of the slope is the steepness, right, or like the way it's moving across. So do you see how the pink line is actually a steeper line than the green line, okay? It's how it moves across the graph, right? This one is a little bit more, this is closer to being flat than this one, okay? This isn't close to flat, but it's closer, right? So this one is a steeper line, so it's going to have a higher slope, okay? And again, I'm not expecting you to fully understand how to develop that idea. We will practice that and a little bit more, okay? So if I were to take the green line and try to write an equation for that, what would I get? Well, we already talked about that it's distance equal to rate times time, so hopefully you came up with something like distance is equal to 30 times t, okay? And now what I have here is I have all of my information for each of the cars expressed in both different ways, right? So I have an equation for both of them, I know the unit rate or the speed at which they're traveling for each of them, and I have them both on a graph, okay? And so what I'm going to expect you to be able to do is take any of these, right? If I give you a graph, I want you to be able to pull the unit rate out of it, and then I want you to be able to write an equation for it, okay? And these are just going to be basic, simple equations. Proportional relationships are pretty easy to write because there's not very, I shouldn't say easy, sorry. They're very less complicated because they typically only have one moving part in them, right? So it's going to be your independent variable, your dependent variable compared with your independent variable, and then the unit rate or the slope there, okay? So let's talk a little more about that, okay? So let's take a look here, all right? We're going to compare Captain Picard and Geordi LaForge, right? If you're not clear who these are, this is the Starship Enterprise, okay? These are characters from the show Star Trek Next Generation, right? And if you haven't figured this out by now, okay, which I'm assuming you probably have, is that I am a kind of a let's say I kind of like science fiction stuff. I don't know, maybe you've seen that or not. But anyway, if you're not familiar with these characters, the Star Trek The Next Generation was a show back many years ago. Great show. Fantastic show. Check it out. All right, anyway, we're looking at how quickly Captain Picard and Geordi LaForge can both type, right? Also, Geordi LaForge, right? His real name in real life, the actor is LeVar Burton. Maybe you've seen him in a show that maybe some of you watch called Reading Rainbow. I don't know. Another great show for kids. So check that one out. All right. Anyway, we're looking at Captain Picard and we're looking at Geordi LaForge, and what we want to do here is we want to say, okay, we want to compare them. All right. Well, I want to know who is the faster typer. Okay. Who can type more words per minute. All right. So let's go ahead and take a look. So if we're going to create a, let's find the unit rate here, okay? We want to find the unit rate for Picard, okay? Go ahead and if you can figure out how many words he types each minute. All right, well, hopefully you said that he types, where's the other one? No? Is it not in here? I guess not. Anyway, so hopefully you figured out that he types at 50 words per minute, right? Yes? Okay, and that's why my equation here is y is equal to 50x. Now, your variables might have been something else. You might have had something like words is equal to the rate, right? The speed at which he types times either maybe time, or maybe you had the words is equal to the rate times the number of minutes, okay? It doesn't really matter, but what we should do is we should define each of these things, right? So we'll say that y is words typed and x is minutes, okay? And what I really should do is I should say something like let x equal minutes, and then y equal words typed. Okay, then I don't have to really worry about it. Okay, so we found the unit rate and then we plugged it into an equation. Excuse me. Now let's talk about Geordi here. Okay, so he is going at 60 words per minute, right? So this would be here. We're looking at this will be 40, and this is 120. Okay, and looking at this, I'm going to just kind of go across and I'm going to find a point here and say, he types 220 words in 2 minutes, right? And so let's look 240 words in 4 minutes, right? So if I divide those, 120 divided by 2 is 60, right? So my rate is 60. And I'm going to use the same thing, minutes and words typed. So I can look at this and I can say, all right, Captain Picard types at less of a speed than Geordi does. Okay, and what I could do here is I could say let's find one. Let's see, 5 and 250. So 5 and 250. So this would be like Captain Picard would be like right around here, and my line, let's see, and he has 2 at 100, so it's about there, and you can kind of see that his line would go like this. Okay, and you can see that Geordi, excuse me, can type at a quicker rate. Good. All right, moving on. I've talked a couple times about this idea of independent variable and dependent variable. I think you've talked about the science also. So independent variable is the thing we change. It's going to be the stuff, right? It's the unit that describes the stuff. And if you're in my class, you understand what I mean by stuff. When we divide, division is really just you have a total amount of stuff, and we're going to divide it into groups to figure out how much stuff is in each group. Okay. Typically, when we do unit rate, that's what we're having to talk about here. Okay. And so the dependent variable, right, is going to be the thing that changes based on what we change, right? So in that previous one, we changed the number of minutes, and then we look to see how many words you can type. All right. So we're measuring. What are we measuring? We're measuring how many words you can type. We're using the minutes as the thing to determine what that is. Okay, so that's what the dependent variable is. All right, so dependent is typically y because it's going to go up and down, and the x values are typically the x values are dependent. A lot of times we use time values there. So not every single time, but the vast majority of the time when you see a time unit, you'll be talking about x, and oftentimes we use money as one of these things, and that'll almost always be on y. Okay. All right, let's do a little independent practice. Go ahead, you try to do this, and then answer the questions that I've put on the side there. Okay, so what we can do real quick is we can say, all right, we've got 3 pounds, right? LBS is the abbreviation for pounds. So 3 pounds is $18, right? So this sort of tells me here the cost of squid based on weight, right? So that means we're changing the weight, and I have the cost, because if you look at this, you're going to need to figure out dollars per pound. Okay, so as soon as you look at this, you can look and you can say, all right, pound is this is the stuff that I'm changing, right? And this is this is what I'm measuring. So this is going to be y, and this is going to be x, right? So this is my dependent variable, this is my independent. I'm sorry, this is my independent variable, and this is my dependent variable. All right, so I've got 18. I'm going to divide that by 3, and I get $6 per pound. Okay, well, this is my rate. Okay, so this means that let's let W equal pounds, okay, for weight, and we'll let maybe C equal the cost in dollars, right? So what does my equation here look like? I mean, it's going to be cost is going to be equal to 18W. Okay, and maybe you wanted to use X and Y, so then a W would be, instead of this, cost is the thing I'm measuring, so this would be Y, so it'd be Y is equal to 18X. Okay, good. All right, let's try this one. All right, so hopefully it's been observed that a particular plant's growth is directly proportional to time. It's measured 2 centimeters when it arrived at the nursery, and 2.5 exactly 1 week later, right? So it's going 0.5 centimeters per week. Okay, so we want to determine the function that represents the plant's growth and graph it, right? So again, we're to do how much it goes per week. So if it's 0.5 centimeters per week, right? I'm not going to graph it right now, but we can determine that we can say that this is going to be X and this is going to be Y, right? So if I'm going to say Y is equal to rate, right, or times X, the rate here, so we're going to get Y is equal to 0.5 times X, okay? Where Y is, and we'll do this, let X equal the number of weeks, okay? And Y is the centimeters it grows. Okay, thank you for watching. I'll see you guys soon.